Hi everyone, welcome to this video in which I'm going to be talking to you about securing and attacking Java Spring Boot apps. Now, in this video, we're going to be looking at Java Spring Boot and some of the security issues that you're likely to deal with, and of course, some of the defenses that you need to apply to secure your Spring Boot apps. Now, I'm going to be doing this as a live demonstration on AppSecEngineer. And of course, if you want, as always, to learn these things, or if you want your team or your developers to actually get a detailed understanding of this through hands-on labs, you should be checking out AppSecEngineer and getting a plan on AppSecEngineer. Now, let's get started with understanding Java Spring Boot and Spring Boot and security issues around Java Spring Boot. Now, here I'm going to just go ahead and start filtering out the courses around Spring Boot, and you'll see that there are a ton of courses around Spring Boot. You have everything from insecure deserialization to cross-site scripting to path traversal to object authorization, SQL injection, of course, the big one, XML external entities, cryptography, password storage, and so on. Now, I'm going to take you through some key things that I think are very, very critical from a security perspective for Java Spring Boot applications. We're going to look at that and we're going to see the defenses. And we're going to do all of this through labs. I'm just going to walk through AppSecEngineer labs and you can actually see how they can be done and how you can actually experience this in the real world as well. Now, let's start with the first one, which is object authorization. Now, this is actually a pretty serious issue. This really comes from access control issues, right? With object authorization, it's really access control issues that are causing this problem. It's basically when you have multiple tenants or multiple levels of authorization in the system, and a user is able to access things that they should not access. So let me give you a simple example. Let's say I have a system that generates or allows me to access my bank account or some credit card account, whatever it is. By tampering with its parameter or changing the ID parameter on the application, if I'm able to access somebody else's statement or somebody else's records, that is an object authorization flaw, or it's also commonly known as BOLA, or broken object level authorization. So that is what it's called, or broken object level access control issues. I'm not going to go into the vulnerability in detail. I'm going to really look at the lab as a way to get into the vulnerability itself. We have, as you can see, an attack and a defense lab. And I'm going to get started with the attack lab. While we're at it, I'll also quickly show you the defense lab. Now, this vulnerability is also called insecure direct object references, and that's really why the lab is called insecure direct object references, or IDOR. So it's called BOLA, IDOR. They pretty much mean the same thing, right? So that's the idea behind this particular lab. So as always with the AppSecEngineer lab system, what you need to do is spin up the lab, wait for it, and then of course you can walk through the entire thing. You have instructions on how you can go ahead and start working with the lab, and you're essentially going to start working with the lab as soon as it's done. So this is how it's going to work. So this is a attack against object level authorization, and the scenario that we have is we have some kind of a financial trading application. The user is logged into their account on one, and by changing the ID in a particular URL, they are able to access somebody else's account because of a route where there is no object level authorization enforced. And that's really the scenario we're going to be dealing with. So let me access the lab and let's take a look. The instructions are right here, but I'm going to move this over to another screen because I want to actually focus on working on the lab itself. So let's access the terminal and let's start running the steps that we have here. I'm just going to copy paste the instructions, build a Docker container for the application to run. And I'm also, after that, I'm going to run the Docker container. Now, in the meantime, you will see that let's actually look at the vulnerability here. Now, the vulnerability really comes from one single route that we have implemented here, which is actually causing all the problems. And it's also been highlighted in the instructions. So in the user service, you have the vulnerable scenario here. So you'll see that there is a get profile function. And this looks very simple. This looks like, okay, this is completely normal. There is a get profile function and this user repo where you pass an ID. And once you pass an ID, a user repo find by ID, and you just basically pass an ID into it. And then if you get a response, that user's profile is pulled up by the application. On the surface, this doesn't look wrong, but really this is a problem because we are not checking if the ID passed by the user is in fact the user's ID itself. And that's really where the access control issue comes from. So that is the problem with this vulnerability here. and we are running the application. Let's access it /login. It does take a little bit of time to spin up the application. It is a Java app. First, we're going to register a user, give it a password, we're going to create the account. I'm also going to create another user. I'm going to call it AppSecEngineer at test.com. AppSecEngineer. We have two users that we have created. Now let's actually go into the login page and log in. And once we log in, we should see that I have logged in to this. Now, if I go into the profile page or the profile route, I get my profile. But if I change, so this is again the profile route, but if I change the ID in the profile route, I get access to somebody else's profile. And this could be obviously much more sensitive than this is right now, right? This is because there is no real authorization check enforced on this. Even if the developer had done a simple authorization check enforced at this level, then this wouldn't have happened. So if you look at the defensive example here, you'll see that we have fixed it in the form of a very simple fix, actually. It's not that complicated at all. Now let's look at the fix. So what we've done here is we've added one layer of authorization, and we've said, okay, get the correct user with the session. So you get the principal from the auth service that you have. So you have an auth service, and the auth service basically deals with the session token, and it maps the user based on the session token and so on. So this is essentially, it validates the identity of the user through the auth principle. And once that is done, you take this current user from this ID on your side, which is a server-side context of that user, and then you check whether the ID sent by the user matches that ID. And only if that matches, only then return some value, otherwise don't return anything. A simple thing like this will ensure that you don't have authorization issues. So Java Spring Security has a whole bunch of things that you can do to do this. You can, of course, implement it like this. You also have additional Spring Security parameters that you can use to do role-based access control related parameters. So these are the kind of things that you can actually, your developers should be learning when they're implementing apps in Java Spring Boot, right? Understanding how these kind of patterns work. And all of this, of course, is covered in our course on Java Spring Boot. So you'll see that it details all of this stuff. It gives you the vulnerable code and so on. So this is something that you have in AppSecEngineer, and just to give you an idea of what kind of vulnerabilities you're dealing with in Java Spring Boot. Let's move on to another vulnerability in Java Spring Boot, which is related to password storage. In password storage, now most of us hopefully don't have to store passwords, but a lot of us still do password storage, right? So in password storage, the thing that you have to deal with the most critically is the fact that if you store your passwords in a weak hashing function, or using a weak hashing function, or a weak encryption format, or an encryption algorithm, you are essentially in deep trouble, simply because if somebody gains access to that data, they can easily crack the hash or crack these user passwords and gain access to a ton of user passwords. And this is borne out time and time and time again. We've seen this in the Adobe breach, the LinkedIn breach, we've seen it in the RockQ breach, and even after that, we've seen this in several other password-related breaches that have happened, so on and so forth, right? So you see this happen very commonly. So let's look at a lab that deals with password storage. So in this case, we're going to have a lab where we have two modes in the lab. One is a insecure mode where we're going to use SHA-1 to hash our password and store it. And the other, we're going to use a key stretching algorithm to do the same thing. Now, in this case, we're going to use bcrypt as the key stretching algorithm. Now, bcrypt, the reason why we are using bcrypt or any key stretching algorithm is that it slows down the process of hashing a password. Now, why is this important? Hashing was never meant to be a password protection thing, right? Or meant to be a password security thing. It was meant to be to validate integrity of two pieces of data. So when hashes started being used for passwords, yes, it was great because very fast, you could validate things very fast. It looked also pretty secure. But the problem really is that when you use a hash function, you are really dealing with that speed, right? So especially with a simple hash function like SHA-1 or even SHA-256 for that matter, it's vulnerable to these brute force attacks because I can just literally try thousands and millions of combinations with solid hardware and I can crack the hash by just comparing hashes. Whereas with a key stretching function, it purposefully slows down the process of hashing, adding encryption or HMACking to the process, and it also adds multiple rounds of encryption and hashing to the process, and only then it generates the hash. So bcrypt, for instance, uses Blowfish, which is a pretty strong encryption algorithm written by Bruce Schneier. And Blowfish, which is the encryption algorithm, is added to the hashing process. Multiple rounds of it is done, and then making these kind of brute force attacks impractical, especially if you enforce both strong passwords and you have a strong key stretching algorithm that you're using. So let's actually go ahead and look at this lab. And in fact, in this lab, we are also going to crack a hash, right? That's going to be fun times. So let's look at how that works. I'm going to quickly open up my terminal, and as always, I'm going to start up a Docker container. Now, most of the apps that we use here will be built using Docker containers simply because it's easy to run the app from that container. Now, let's look at the secure and the insecure modes of doing this. So we have a user service, and I'm sure this is somewhere in here. Yeah, we have the secure and the insecure mode. So you'll see the insecure mode, we're using SHA-1, and we're just hashing the password that comes from the user, nothing more. This is bad. One, it's bad because we're using SHA-1. Two, it's made worse because we're using SHA-1 without any kind of a salt. And salts they add a little bit of randomness to the password hash, and that's ideal. But even then, it's not a good idea to use a salted, just simple hash to protect your password. So we have our application, and this is running as a REST API. And this is not running as a UI application. This is running as a REST API, which means that we're going to interact with it with curl, very simple with curl, right? So we're not going to use anything else. And we're using bcrypt. Now, one of the things you'll see is we're using bcrypt with bcrypt password encoder, and we're using the Spring security framework with bcrypt password encoder. Now let's actually look at what bcrypt password encoder can do for us. And this is the Spring security documents. Now, bcrypt password encoder by default uses decrypt strong hashing function, which is good. The default value is 10, which means that we are using the strength parameter. So the strength parameter is something you don't have to use. By default, it's going to automatically use 10, which is pretty good. We are using 12 in this particular case. You'll see that we are using 12. And it's very simple. You just have to use this. And this makes it easy, right? Especially when you're dealing with libraries. You don't want to think too much about what is the strength factor, all that stuff. If your library can give you a strong default, then you don't have to worry about it. So you don't have to worry about the rounds and stuff like that because the default itself is pretty strong. But in this case, we've decided to go with a stronger than the default mode. So let's actually interact with this application and first generate we're going to say secure mode false, and we're going to generate our mode set to insecure. So this is our application mode is set to insecure. Let's actually sign up. So saying John, password, secret password, sign up. And this is going to give us a SHA-256 hash. So this hash is obviously not great. And how do we prove that? So we have CrackStation. And in fact, if you see CrackStation, and you can use this as CLI tools as well, CrackStation just happens to be easy, accessible to everyone. And when you run this on CrackStation, you see it's literally in a matter of fraction of a second that you can see that CrackStation has been able to crack your password with the term secret password, which is really, really bad. Obviously, so easy to crack this password. So if somebody finds this password in an SQL injection attack, forget about it. You're essentially hosed at that point. But now let's go ahead and change it to secure mode and use the same password. And you'll see the password is now using bcrypt. It's a much harder password. It's very hard to crack. And in fact, this doesn't even have bcrypt cracking capabilities. So you'll see that this is not going to give you any result. Should not give you any. It says unknown hash format. And yeah, even if you use cracking tools, it might take a really, 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 really long time, basically making the adversary cost very, very high, kind of pointless. So if you are dealing with passwords, definitely use key stretching with strong defaults rather than just using hashing functions. This is something that you should be it's very critical for you to focus on. All right, let's move on to another vulnerability, which is, let's go ahead and pull up AppSecEngineer. And by the way, for each lab, you have challenges that are like this, so you can actually solve those challenges and get better at your skills. Let's look at a very interesting vulnerability that we have called insecure deserialization. And this is a real serious issue and one of the key aspects of the OWASP top 10, which is data and integrity driven attacks. Now, insecure deserialization really happens because you have your application is accepting certain serialized formats. It could be XML, it could be JSON, it could be YAML, it could be TOML, it could be several other serialized formats. Now, basically, serialization essentially means you take an object in, let's say, Java or Python, or whatever it is, and then you convert that into a serialized object. You basically convert that into objects that can be either stored on the file system, transported across the network, something which is commonly accessible. And then the application that is receiving that payload will essentially deserialize it, which is basically unpack that payload and then take in the data, consume the data, right? That's basically what serialization and deserialization means. Now, imagine that an attacker or an adversary packs some malicious payload into the serialized data set. And once the attacker does that, the victim system or the victim application receives this serialized data and deserializes it. And because it deserializes it, the deserialization library is vulnerable. The data just blows up. It's like a explosive, right? Just going off. So let's look at this as a lab. And in this case, what we're going to do is we're going to look at a very interesting vulnerability in Snake YAML. So Snake YAML is a library that allows you to handle YAML in Java applications. And this was vulnerable to an insecure deserialization because Snake YAML, when it finds some YAML with some executable payload, it actually executes that code on the backend system, which is really, really bad. So this is something that is terrible and very, very dangerous. And this is something we're going to look at in this particular lab as we spin it up. Now we've spun up the lab and we're going to actually go ahead and move the instructions over to the next page as always. And I am going to go ahead and run the lab. As always, open up the terminal and start copy pasting the instructions. And you can see how easy it is to do this on AppSecEngineer because it's just hands-on and the instructions are right there. You spend very little time, your engineers spend very little time trying to figure this stuff out, which makes it difficult for them to learn. So it takes very little time. Within 15-20 minutes, you've actually learned a ton of subjects on AppSecEngineer because of the lab system that we have. And the labs are, since they automatically learn the concept in a lot more serious way. So this application, if you look at this application, we have two YAML files. One is just a simple YAML file, which is not doing anything bad. The other is a dangerous YAML file. Now, what this is doing is that it is forcing the Java application in the background to run a remote Java class, which is obviously terrible because running a remote Java class essentially means loading some third-party code on that application server. And it's going to just, in this case, it's not doing anything seriously harmful. It's just calling an HTTP URL. And I'm going to put in some details about this very soon. So that's what it's doing, but it can do way worse than this. This can literally compromise the entire backend server with this payload. So if you look at the insecure deserialization example here, you will see the problem with this. So here we are handling YAML and we're literally loading YAML. We're doing nothing else. Because the library behaves in a certain way where if it sees this sort of double exclamation mark, it realizes that that is an instruction to be loaded, which is code to be executed. And it honors that instruction, which is bad. Your parser should never behave like that. So if you see the secure version, you'll actually see a departure from this approach. Let's actually see the secure version and see the code in the secure version. And you will see you are passing something called the safe constructor, which is loading the YAML, but it is not going to honor the double quotes code execution instructions. So that's really the difference between the secure and the insecure version, which is so strange because libraries should be secure by default, but not in this case, right? A lot of libraries are not. They don't really think about security in many cases. So let's look at this application and wait for it to spin up. It does take a little bit of time. Yeah, looks like, okay, so this very simple. Just have to upload the file and we're good to go. So let's download this file. Let's download the users.yaml. And if you see this, it'll just say, hey, first name, last name, email. That's it. Very simple. It just processes the YAML like a regular piece of input. Now, let's actually go ahead and do something with this. Let's set up a listener like an attacker would on our lab machine and say, hey, let's wait for connections to hit us here. Now, this is us behaving like a real attacker. So what we're going to do now, we are going to change the IP address of I'm going to say, hey, contact this. And we're going to download this file, malicious.yaml, and not very well named. not very subtle, but nevertheless. So we're gonna upload this, and if everything works, it should hit our, if the attack works, there should be a request coming in this. And you see there is a request coming in on our web server. So you see that you can literally get this to load any code you want. In this case, it's just making an HTTP call, but it can load anything else. It can actually contact the backend database. It can start running commands on the backend server. Anything goes. So this is something that can be really, really powerful in terms of the attack possibilities. This is the kind of stuff that can be really dangerous, and your team a lot of times will not be aware of these sort of issues. And this is really where the hands-on lab experience becomes so important with AppSecEngineer, right? So this is something that I wanted to just showcase. Now, of course, we have a lot of courses on Spring Boot. I'm not going to cover all of them, but I just want to give you an idea of the critical issues, some of the critical issues that you'll see, especially as you're building web applications and REST API, and nowadays AI-driven, AI-enabled web applications as well. You need to have a good understanding of security issues to understand and fix them and understand and review them. And a lot of times, even if you're doing AI-generated code, you need to be able to review these issues in a lot more depth to be able to understand what it's actually doing. Because a lot of times they just implement libraries like snake YAML and just do YAML.load, and you are vulnerable to insecure deserialization. It just happens. So that is something that you need to think about in a deep way and a meaningful way. So thank you. I hope you enjoyed watching this video. If you do like it, please consider liking this video and subscribing to our channel. It really helps us put out a good deal of interesting content like this as well. Thank you so much. See you next time.